Hello everyone. So today I'll be discussing few gate questions. One related to shear reinforcement design. Then after that I'll move towards shape factor and plastic analysis. And one problem related to deflection of beam for revision. I hope I'm audible. Anyone can respond.
Yes, ma'am.
Okay, thank you. So I'll start with shear reinforcement design of RC beam. So the question is question number 53 of set 1 gate 2022. A reinforced concrete beam with rectangular cross section, width and effective depth is given to us, is made of M30 grade concrete. It has 1% longitudinal tension reinforcement of Fe415 grade steel. The design shear strength for this beam is given, which is 0.66 Newton per mm square. The beam has to resist a factored shear force of 440 kN. The spacing of two-legged 10 mm diameter vertical stirrups of Fe415 grade is in mm. We have to give the spacing of vertical stirrups, and what is the grade of steel for vertical stirrups? It is Fe415, and we have to give our answer in millimeter by rounding it off to the nearest integer. For RC design, you can refer to lecture series on design of concrete structures by Professor N. Dang, Department of Civil Engineering, IIT Kharagpur. So I'll start with the question. This is a question of vertical spacing of vertical stirrups. We need to determine the spacing of shear reinforcement, which are the vertical stirrups in this case. The important thing is we have to give our answer in mm, and moreover the grade of steel for stirrup we generally use Fe250, but here it is given as Fe415. Okay, so we have to keep this thing in mind. So it's a very simple question. We just have to follow the steps according to the code. So first of all, for designing the stirrup spacing, we need to calculate the nominal shear stress first. So nominal shear stress, we the formula is Vu by Bd, where Vu is the factored shear force. The factored shear force is given to us in this case as 440 kilonewton. So we'll do it in mm, divided by B is given to us as 300 mm, and D, which is the effective depth, is given to us as 580 mm. So can you please calculate it for me? What is the answer you are getting? Anyone? So I am getting for this as 2.528 Newton per mm square. I hope you are getting the same. So first of all, we
Yes,
have
ma'am. 2.52.
great. So it is better if you solve it with me, because then only you'll understand it better. So I'll give you a similar question of gate, I think, to 2018, which is totally similar to this. Just you have to follow these steps and do the calculations. So the spacing of stirrup can be calculated using the formula as 0.87 Fy. Fy is given to us in this case as 415 divided by area of stirrups. So area of stirrups, we will calculate, it is a two-legged stirrup with diameter 10 mm. So the area will be twice of pi by 4, since it's a two-legged stirrup, so twice of pi by 4 d square, which is 10 in this case, diameter is 10, divided by tau v. Tau v is given, we have calculated as 2.528 minus the shear stress carried by concrete, which is 0.66 given to us, multiplied by B, which is 300 in this case. Can you quickly calculate this for me and give the value of SV in this case? Better to use a calculator in your laptops, so that while solving the question during gate, it will be easier for you. If you'll use normal calculator, then it will be difficult. that time?
I'm 98 millimeters.
98. Okay, let me check. I am getting as 101.20. Please check your calculation. I'm getting SV as 101.2. So you have to do a lot of practice, otherwise these small mistakes, although your answer is very similar, but the range was 100 to 102, I guess. So in that way it could be wrong. So answer is SV should be less than 101.2, since we have to round it off to the nearest integer. So I'll call SV as, so my answer I'll give SV as 101 mm. So I think the range was 100 to 103, something like that in the key. Also, although this step is not required here, but we can also check for minimum shear force requirement. So if this value of SV, the value of SV we got is less than the minimum shear force requirement, then we have to give the minimum shear force requirement. Although in this case it is not, but still let us check कि minimum it is satisfying the minimum shear force requirement or not. So according to minimum shear force requirement, the codal guidelines say SV should be less than 0.87 Fy is 415 multiplied by ASV, which is a two-legged 10 mm diameter stirrup. Therefore, twice of pi by 4 d square divided by 0.4 times of b. B in this case is 300 mm. 300 mm. So we get the value of SV in this case as, please calculate this for me. I'm also calculating. Let us see. So I'm getting it as 472.6133 mm. So in this case, our answer is right, which is 101 mm, because the minimum shear force requirement is spacing should be less than this. So our answer is correct. If our answer would be coming more than this, then we have to give this answer. Okay, so in the minimum shear force requirement, we should also check if the spacing satisfies the minimum shear force requirement. If our spacing would be more than 472, suppose if after calculation, if we would have got the answer like, let's say 500 mm, then we have to provide the minimum shear force requirement, and the answer would be then 472. Although in our case it is fine. So we should also check for minimum shear force requirement. This step was not required for this question, but maybe for some other question this may be required. So I've given you the answer. The SV in this case, the spacing of the vertical stirrups should be 101 mm. So answer was asked in mm, so we'll give the answer as 101 mm in this case. Okay, a similar question was asked in GATE 2018, which is totally similar to this. So I'll expect to please follow the same steps and try to solve this problem. I'll give you some time. So similar question is there. Just follow the same steps I've given you. First of all, find out the nominal shear stress. The nominal shear stress, I'm giving you the formula. The nominal shear stress is VU by BD. And just let me know what you are getting the value of nominal shear stress as. VU in this case is, what is the value of VU in this case? Is it given? Yeah, 200 kilonewton. So 200 kilonewton is given to us. So let's calculate it in mm. What is the value of B? B is given to us as 250 mm, and D, the effective depth, is 350 mm. So in RCC, we just have to study the codal guidelines. We should study the codal guidelines because any question can come out of those guidelines. So you just
2.28.
2.28. Let me check the answer. Yeah, very good, very good. The answer is correct. The answer of tau v is coming out to be 2.286 Newton per mm squared. Now please use the same formula for stirrups, which is used in this problem, and find out the value of spacing. Please try to do it accurately first and then try to increase your speed as well. You have to use a similar form, the same formula. Just put the values given in that problem. If you want, I can. Do you want me to write the formula here? So this is the formula you have to use and the values from that question. Spacing of stirrup in this case. Others, please all participate. Otherwise, it will be of no use for you. Because in RCC, there is no major concept. You just have to follow the steps. And question is very easy. If you know the formula, you just don't have to use much of your brain. You just need to put the values in the formula and find out the answer. Anybody got the value of SV? Spacing? Okay, Nikesh, you can either say or write in the comments.
Ma'am, 81.98 millimeter.
Great, great. So you just have to use the same formula, SV equal to 0.87 FY ASV divided by but in this case, see, in this case, the value of Fy is given to us as Fe 250. We are using Fe 250 grade steel here for stirrups. So therefore, we have to use, instead of 415, we have to use 250 in this case. Otherwise, the problem is totally same. So you see that in 2018 they gave us this type of problem, and similar question in 2022. Same formulas you have to use. So they just some problems they do just modify the things and give the similar problem to you. So I hope it is clear. Anybody is having any problem with this? You just need to put the values in the formula. One thing you have to keep in mind, one thing that the important thing is, in this case, the allowable shear stress, the maximum allowable shear stress is given to you, that is 2.8 Newton per mm square. So when you are calculating your value of tau v, the value of tau v should be less than the value of tau c max. If so, in this case, the value of tau v we are getting as 2.286 Newton per mm square, and tau c max is given to us as 2.8 Newton per mm square. So it is fine. If the maximum allowable shear stress is more than our tau v value, then it is fine. If in case we would have got the value of tau v more than 2.8 Newton per mm square, then we have to redesign the section. Okay, so maybe in the option, sometimes in case of optional questions, so we might take the answer as we have to redesign the section. Okay, so in any case, tau v should not be more than tau c max. Okay, otherwise if it is so, then we have to redesign the section. So in this case it is okay. So we'll proceed further and calculate the spacing of vertical stirrups, and which is very easy to do, and you just need to remember this formula. SV should be less than equal to 0.87 Fy ASV divided by tau v minus tau c into b. So you should maintain a very thin maybe notebook in which all the formulas should be written, and you should it's my just opinion, you should read it every night before sleeping, so that all the formulas will sink into your mind. And just because of not remembering the formula, you should not miss any question, because that will be very, you'll feel very bad because of that. So just remember all the important formulas. Like this formula we are getting in every alternate gate years, so it's better to remember these formulas. So a similar question from another gate year, maybe gate 2016 question is this. So as per IS 456 2000, for the design of reinforced concrete beam, the maximum allowable shear stress depends on. So this is a question which is entirely based on the codal guidelines. So they are asking, for the design of reinforced concrete beam, the maximum allowable shear stress depends on. So maybe you want to answer, just a guess, whether it depends on the grade of concrete and grade of soil, and whether it depends on grade of concrete only, or grade of steel only, or both the grade of concrete and percentage of reinforcement. Anybody would like to answer? There's nothing right or wrong, just I want to know. You can also guess what should be. So it's totally based on your IS code. Okay, any other? Just a guess. You should. We are just practicing here. Okay, and maybe I should. Okay, maybe Harini. What? Let's see. Harini is saying A. Okay, and what about others? Just a guess. Okay, B. Mm-hmm. D. Let's see who's right then. So okay, so let's check your answer then. So it was asked that maximum allowable shear stress depends on. So the answer is this. This is a table number 20 from IS code. So we can see that the grade of concrete and tau C max. So the answer is B. Whoever gave the answer B is right. So according to the IS code, the value of tau C max only depends on the grade of concrete. There is nothing mentioned about steel or anything else. So the answer is the tau C max depends on grade of concrete only. This is the answer. Okay. So please keep this in mind. So see, it was directly asked from the table of IS code. Okay. So this is just one more question from this section. So the question is, the spacing, it is also I think a gate question, or maybe it can be asked in future. So the spacing of stirrups in a beam, four options are given to us: decreases near the support, same everywhere, depends on the size of the beam, or increases near the support. So we, in a beam, we provide stirrups, right? So this is longitudinal reinforcement and we provide as a vertical stirrups. So they are asking, the spacing of this stirrups, the space between this stirrup, decreases near the support, it is kept same everywhere, it depends upon the size of the beam, or it increases near the support. So four options are given to us. You can check, you can maybe just a guess, you can all write in the comment your opinion. We are not judging anybody. Anyone else? Harini? Harini is saying C, and others I can't see on the screen. Just a guess, maybe just we'll check. We are not judging anybody here. Okay, then I'll tell you the answer. So the answer is, the spacing of the stirrups in a beam decreases near the support. Okay, so the answer is A. How is it? Because suppose, let's say a simply supported beam. Okay, so when a simply supported beam, when we draw the shear force diagram of this beam, so we see that shear force is maximum near the support, right? The shear force is maximum at the support. Therefore, we need more shear reinforcement. Obviously, we'll provide more shear reinforcement where shear is more critical, right? So shear is more critical near the supports. So we will provide more reinforcement near the support. Okay, so suppose this is longitudinal reinforcement and this is shear reinforcement. Okay, so we will provide more reinforcement near the supports. Therefore, the spacing between the stirrups will be less near the support, because spacing less means more reinforcement, right? So the answer is it will decrease near the support. So why decrease? Because near the support shear force is maximum. Therefore, we need to provide more shear reinforcement there. More shear reinforcement means spacing less. right? I hope it is clear to everyone. Is it clear, right? Ma'am, please. Option C of, no, it does not depend on the size for a particular thing. It does not depend on size of the beam. You are asking about this only, right? So spacing, yeah, you are. I think yeah, I got your question. That indeed the spacing depends upon the size of beam, but it does not, like, spacing change, the change in the space does not depend on the size of the beam, right? So the other question they wanted to ask is the spacing, how the change in the spacing depends. So change in the spacing does not depend on the size of the beam, although overall spacing depend on the size of the beam. But here they are asking spacing of the stirrups in a beam. They're asking decreases near the support, same everywhere, this kind of things. So according to this context, the answer is answer number A, that is decreases near the support. Okay, although this thing is contradictory because obviously we are calculating on the basis of the shape only, but the intent of asking the question was how the change in this spacing is taking place, or is this spacing changes because of the size of the beam or not. Okay, so the context was different in this case. It decreases, it increases, or it is remaining same everywhere, although this is a little bit contradictory. But you got my point, right? It is decreasing near the support. Why it is decreasing, then you can see. Maybe in any other way they can ask this question. Maybe I have not framed it very well. Okay, any confusion? Okay, so the point you got, right? Why it is less near the support, because the shear force is maximum. Now this thing is over. Now I'll move towards the next thing, that is plastic analysis. So plastic analysis, this is question number 38 of set 2 gate 2022. For square steel beam, cross section is shown in the figure. The shape factor about ZZ axis is S and the plastic moment capacity is MP. Consider the yield stress. Yield stress is given to us as 250 MPa and the value of A is given to us as 100 mm. So it is a square cross section, but it is kept in this way. Okay, all the sides are equal. The values of S and MP rounded off to one decimal place are. So we need to calculate the value of shape factor as well as the plastic moment capacity. Right, four options are given to us. Okay, so I've given the reference for this problem. So if you want to go in deep, you can refer to this lecture. It's a 2-mark question with negative marking as well. So let's start with the problem. We need to find out the value of shape factor as well as the plastic moment capacity. Let's find out. So shape factor we calculate is the ratio of plastic moment capacity to the yield moment. Okay, so we'll calculate MP and My and we will put this in this formula MP by My and we will get the value of the shape factor. Now how to calculate the value of MP and My? MP is the product of yield strength multiplied by section modulus, plastic section modulus. Okay, so how to calculate the plastic section modulus? The plastic section modulus, the formula is A by 2 y1 bar plus y2 bar. Okay, the plastic moment section modulus, the formula is A by 2 y1 bar by y2 bar. In order to calculate the value of MP, we should know the value of ZP because MP is the product of Fy into ZP. Okay, now how to calculate ZP in this case? Let's say this is area 1 and this is area 2. Okay, so A is total area. What is the area of this section, this cross section? This is a square cross section, right? The area of square is 100 by 100, right? The dimension are given to us as 100 mm. So the area will be 100 by 100 mm. This is the area of the cross section. So area is known to us. Now we'll calculate y1 bar and y2 bar. So what is y1 bar and y2 bar? Y1 bar is nothing but this CG of this first part. Y2 bar is CG of this second part. So what is that value? Since this is a triangle, right? So the CG will be at, let's call this length as L. So CG will be L by 3. I hope you agree with me. Since it is a triangle, so the CG will be at L by 3. Right? So Y1 bar is L by 3 and Y2 bar is also L by 3 because they both are same. Now what is the value of L? Right? Let me draw it here. So you got the point, right? ZP will be A by 2. A in this case is 100 square divided by 2. Y1 bar is L by 3 and Y2 bar is also L by 3. And what is the value of L? We will see now. So L we assumed as this, right? Now, how to calculate the value of L? This is given to us as 100 mm. This is also given to us as 100 mm. This is angle 90 degree. So what will be this total length? This total length, which is 2L. 2L will be equal to 100. 2L will be equal to under root of 100 square plus 100 square, right? So L will be equal to 2L will be equal to 100 root 2. So L will be equal to 100 by root 2. You got my point, right? Any confusion in this? It's very easy. Any confusion up till this point? So this is the only critical. Should I explain it again? How we are getting L as 100 by root 2? Or it is fine? Is it fine? Should I proceed? This is simple geometry. Okay, so we get the value of L as 100 by root 2. Now ZP 100 square by 2, L by 3, that is 100 divided by root 2 into 3 plus 100 divided by. So anyone would like to calculate this for me? What is the value of ZP we are getting here? Okay, so I'm getting the value as 235.702 into 10 to the power 3 mm cube. So you can check your answer. I'm getting the value as 235.702 into 10 to the power 3 mm cube. Mm cube you got, right? We are multiplying mm square multiplied by mm, therefore mm cube. Now MP will be Fy into Zp. The value of Fy is given to us. The value of Fy is 250 multiplied by Zp. Zp is 235.702 into 10 to the power 3. So MP will be, we'll do this calculation first, will be 250 and the answer will be 58 925 565.09 Newton mm. So we will convert it to, because the answer we have to give in kilonewton meter. So we'll divide it by 10 to the power 6. So answer will be 58.925 kilonewton meter. So this is our value of MP here. So MP will be 58.925 kilonewton meter. So MP is basically the product of Fy into Zp. The main thing we need to calculate is the value of Zp in this case. So Zp, the formula, this is very important formula. Maybe in every other year they ask this question of Zp, in which Zp is involved somewhere. So Zp is A by 2 y1 bar plus y2 bar. The intention of telling you these questions is just see the pattern, the questions which are coming every year, the type of questions, the formulas, the important formulas you should note down. So Zp is very important. Zp is A by 2 y1 bar plus y2 bar, where y1 bar is the CG of the first area, the because z-axis is cutting it into two areas, right? This is area 1 and area 2. So y1 bar is the CG of first area, y2 bar is the CG of the second area. Okay, I'll give you a similar question, but first calculate the value of shape factor also. So we got the value of MP as 58.9, but 58.9 is in this option also and this option also. Now we need to calculate the value of shape factor also. So shape factor is the ratio of MP, that is plastic moment capacity, divided by the yield moment capacity. We know the value of plastic moment capacity, which is 58.925 kilonewton meter. Now we need to calculate the value of yield moment capacity in order to find the value of shape factor. So let's calculate the value of yield moment capacity as well. So yield moment capacity, the formula is similar to plastic moment capacity. The formula is here is Fy into Ze, where Ze is the elastic section modulus. As we are calculating Zp as A by 2 y1 bar plus y2 bar, Ze will be calculated as Izz divided by y, where Izz is moment of inertia about zz axis. So Izz for a square cross section, the value of Izz is the formula you should remember, A4 by 12. Right, A4 by 12. For rectangular section it is BD cube by 12. For square section it is A4 by 12, where A is the length of the side of the square, right? So A4 by 12, and Y in this case is this, which is L. We have assumed it as L, right? So Y is L in this case. What is A4? Y is L, and the value of L is, the value of L we calculated as 100 by root 2. So it is 100 by root 2. So Izz will be equal to A is 100 in this case. So A ki power 4 divided by 12 divided by Y. So Y is 100 by root 2. Okay, so what is the value of Izz we are getting? Sorry, not Izz, it is Ze. So what is the value of Ze we are getting? Please use your calculators to find the value of Ze in this case. So I'm getting the value of Ze as 117,851.130 mm cube. So we'll find the value of My as Fy into Ze. So Fy is 250 multiplied by Ze. So the value of My, it is coming out to be this multiplied by 250. The answer is 29.462 kilonewton meter. Now finally we'll calculate the value of shape factor as MP by My. MP was 58.925 kilonewton meter and My was 29.462 kilonewton meter. So shape factor is 2. So this is the final answer. The shape factor is 2 and moment is plastic moment is 58.9. So answer is option number A. One important thing you should keep in mind for these kind of questions is sometimes they might ask for they might give you different sections and they might ask you to arrange them in order to of increasing value of shape factor. So for some standard cross sections you should learn or remember the value of shape factor, because if you would know that for a diamond section, this is called a diamond section, if you would know the value of shape factor for a diamond section is 2, because it's a standard value for any diamond section, the value of shape factor is 2. So then you need to solve just the half of the problem. You know the value of, you got the value of plastic moment capacity as 58.925, and you already know the value that for diamond section the value of shape factor is 2. Then you needed to solve only the half of the problem. You would tick mark the answer A at that point. Similarly for I section, for rectangular section, these are some standard sections, so please remember the value of shape factor. So in, because if they would ask you to arrange the cross sections in order of increasing shape factor, then you can't calculate the shape factor for all the sections at that moment, because that question will be very lengthy then. So they expect you to remember the value of shape factor for some standard cross section. So this is the important thing out of this problem. Okay, first you should know how to calculate the plastic section modulus, that is very important, and then you should remember the value of shape factor for some standard cross sections, that is the second important thing. Now this is a practice problem which is related to it. Please try to solve it. You need to use the same formula of ZP and MP. You need to calculate the plastic moment capacity of this section about y-axis. So you need to calculate the plastic moment capacity about this y-axis. The dimensions are given to you. Okay, so you need to, how you will calculate MP. The formula of MP I've told you, it is ZP into Fy. So Fy is given to you. Fy is 250 mm in 250 Newton per mm square in this case. You just need to calculate the value of Zp. That is the important thing. And Zp, the formula for calculating Zp is A by 2 y1 bar plus y2 bar. Please try to calculate. Please try to calculate the value of Zp in this case. So there are for a hint, so there are two types of sections, you can say. The first section is these rectangles, and the second section is this web. So this is, let's say this is second section. So when you will calculate the value of A by 2, maybe I tell you. So the value of ZP we need to calculate as A by 2. This is also a gate question. I don't know which here, but it's a gate question, I guess. So P will calculate as A by 2 y1 bar plus y2 bar. Now let's calculate the value of ZP for these two rectangles. Okay, let's calculate the value of ZP for these two rectangles first. Okay, we can't calculate it together. Why? Because because for this web and for these rectangles the value of CG is different. So we cannot just use a single formula and calculate. We need to do this calculate this value of ZP twice. For example, let's calculate the value of ZP first for these two rectangles. So for these two rectangles, what is the area of the one rectangle? The area is, total length is 140 mm and width is 9 mm, right? So area is 140 multiplied by 9 divided by 2. So A by 2 divided by 2 multiplied by y1 bar plus y2 bar. Y1 bar and y2 bar, what are y1 and y2 bar? These are the distance of CG from the axis. So this is the y-axis, because we need to calculate, why we are doing everything about y-axis, because we are asked the value of MP about y-axis. Okay, so the distance of CG from y-axis. So distance of CG of this part from y-axis is entire this distance, the entire distance is 140 mm, so this distance is 70 mm, and the value of CG will be at half, at middle of this. So y1 bar will be 35 mm, y2 bar is also at 35 mm, 35 mm, and we are calculating for both the rectangles, that is why I have multiplied it by 2. Okay. Then again for this web, we will calculate the value of ZP. For the web, the area of this web is, this thickness is 6.1, so 6.1 multiplied by the length of this web is 200 minus 18, 6.1 minus multiplied by 200 minus 18 divided by 2, a by 2 multiplied by y1 bar plus y2 bar. Y1 bar is total thickness is 6.1 mm, half of the thickness is 3.05 mm, and CG will be at half of, even half of this thickness. So CG will be 3.05 divided by 2. So y1 bar plus y2 bar. So it was a little calculation intensive question, you can say, but you need to keep that in mind, that you have to calculate the value of Z2, ZP for these two sections differently. First for the web and then for the flange, or vice versa. Okay, so from this calculation we get the value of ZP as 89.89 centimeter cube. So we need to give the value in centimeter cube. So the answer was 89.9 centimeter cube. I hope you get the question. If you did not get it right now, just note down the question and try to do it yourself. Very simple question. You need to use the value of ZP, that is a by 2 y1 bar plus y2 bar, and then you will calculate, you will multiply it by Fy and get the value of MP. So they might ask you the similar question about x-axis as well. So please note down that we have to calculate it about y-axis. Yeah, this is all about this question. Any confusion in this? Very simple question, just calculation is a little bit tricky, you can say. Otherwise, you need to use a simple formula. Just note it down, maybe in some other way you get this type of question as well. Okay. Any confusion in this? If not, I'll proceed, but please note down this question, or you can also see the recordings afterwards and try to solve it yourself once. I'm sure you'll get that. The other thing I want to discuss today is deflection, is regarding deflection of beam, because I'm repeatedly saying that is a very important topic, deflection of beam. Okay, so it's a GATE 2010 question. The question is in this question there's a cantilever beam PQR. The flexural rigidity of part PQ is given to us as EI, whereas the flexural rigidity of QR part is infinite. So it is infinite for QR part, and the value of PQ is given as flexural rigidity for PQ part is EI. The length of PQ is L, the length of QR is L. Okay, we need to find the value of deflection at R point. So deflection at R point is required to be find out. The answer I have already given to you, 7 by 3 WL by EI. Before starting this question, I just want to ask, if I have this cantilever beam, and if this thing EI and infinite is not given to you, simply it is 2L, let's say, then and W is given to you, then what will be the deflection at R in this case? Anyone would like to answer? If it would have been a simple question like this, cantilever beam with the load at the end, the length is 2L, what would have been the value of deflection at point R? Maybe you want to tell in the comment also, because you need to remember these deflection formulas, because they will be used in every time, in every year this will surely come. I'll tell you, if it would have been a simple case like this, in which you need to calculate the deflection at r. So deflection at r will be PL cube by 3EI. This simple formula you needed to use, and you get the answer as delta R. What is the value of P? What is the value of load here? Which is, it is W. What is the length of the beam? Length is 2L divided by 3. Flexural rigidity is EI for all the beam. It would have been EI, and it would be 8 by 3 WL cube by EI. So this would have been the answer. Okay, if there was no EI and infinite EI in for half part of the beam, but now the question has become a little tricky. We cannot just simply use the standard deflection formulas to get the answer. We will see how we will do the problem now. I hope you got this thing. For the cantilever beam with load at one end, we will use the formula PL cube by 3EI. And what is the theta? If we were asked the value of slope also, so what would have been the value of theta here? The value of theta would be PL square by 2EI. Okay, so this would have been a value of delta and theta, but now they have complicated the question a little bit, and they have made the value of the portion QR as infinitely rigid. Okay, so let's see how would this thing change the scenario. Let's see what if the deflection would increase or decrease. So the question is this now, that this is a cantilever beam with load W, and we have two sections now, P, Q and R. For section PQ the length is L, and for the section QR the length is also L. Now let's see what happens. This has infinite flexural rigidity, it has EI. So what is the change? For this, let's first draw the deflection diagram. So how this beam will deflect for this scenario. This is W here. In this case, up till point Q, okay, up till point Q, the beam will deflect as usual, like this. Will be, let me draw it again. It will be little curved like till here. But after Q, since the part QR is infinitely rigid, the flexural rigidity is infinite, therefore it will not bend. Okay, what do you mean by infinite flexural rigidity? Means it will not bend. Okay, as we increase the flexural rigidity of a portion, it will bend lesser, it will deform lesser. And if we make flexural rigidity infinite for a section, it will not bend at all. Okay, so after this point it will be a straight line. So this is the difference it is making. If it would not have been flexurally would not have been have infinite flexural rigidity, then what would happen? Then it would have a deflected shape, curved till this point. I hope you got the difference. Hmm? Difference is only now, since QR is infinite, is having infinite flexural rigidity, so it will be curved only till point Q, and after point Q it will be a straight line, because it has infinite flexural rigidity, therefore it will not bend. Now how to calculate this? So up till point Q it will bend. Let's see how we will calculate it. Let's call this angle as theta. Since this angle is theta, this angle will also be theta. Let's name everything first and then we'll see. Let's call this deflection as delta 1. Since this is delta 1, this will also be, since we have drawn a straight line, so this will also be delta 1. And this is delta 2. So final deflection for at end R will be delta 1 plus delta 2. I hope you'll agree with me till now. So how to, what are delta 1, delta 2, and how to calculate the value of delta 1 and delta 2? Let's see. For solving this beam, since we need to calculate the value of delta 1, we will, and this so we will, what we'll do, we will shift, this beam is there with infinite flexural rigidity, we will shift W here. So when we will shift the load, there will be a load as well as a moment, right? You know the shifting of load, right? If we have to shift a load, we will shift the load like this and a moment like this. So load will be W and moment will be W into L, because this length was L. So please note this concept. So whenever we shift a load, we'll not directly shift the load, we'll shift the load and we'll apply a moment in that particular direction only, and the value of that moment will be W multiplied by the length which we have, with which we have shifted the load. Okay, so I think this may be a new concept for you, but it is useful in this case. Okay, now delta 1 will be nothing but the deflection due to these two loads, and theta will be the slope due to these two loads. Now we know that delta 1 will be the deflection due to W. The deflection due to W will be PL cube by 3EI. You know that PL cube by 3EI, and deflection due to moment will be, deflection due to moment is ML square by 2EI. What is M here? Moment is M is WL. What is length? Length is 2 divided by 2EI, ML square by 2EI. So you will calculate the value of delta 1 as 5 WL cube by 6EI. So this is the value of delta 1 we got. So what is the final value of delta? Delta is delta 1 plus delta 2. Now we need to calculate the value of delta 2. Delta 2 is nothing but this theta multiplied by this length L. Theta multiplied by this length L. So delta 2 is theta multiplied by this length L. And what is the value of theta? We'll see. So delta 1 we get the value as 5 WL cube by 6 EI. And the value of theta we will calculate as, theta is the slope due to these two loads. The slope due to point load W will be PL square by 2EI. The slope due to moment is ML by EI. What is M? M is WL, L by EI. If you don't understand it right now, please note it and try to read it at your home, because this is very important. Okay, because there is no other way to solve it. Okay, so WL square by 2EI plus WL square by EI. So value of theta we get it as 2EI. I hope I'm doing it right. 3 by 2 WL square by EI. Okay, you're getting it? Any confusion till now? Any confusion? Okay. So the value of delta 2 will be theta multiplied by L. Delta 2 will be, theta is 3 by 2 WL cube by EI. So this is the value of delta 1 and delta 2. Finally, what we will do, we will add the value of delta 1 and delta 2 and we'll get our answer of final delta. So the trick here is to shift the load to point Q and then do the calculations. The important thing was, since that part QR is flexurally have infinite flexural rigidity, so it will not bend, so it will go straight line up till here. Okay, please note this question and try at home. It is a little bit tricky, but just try to solve it, because this concept will be useful in many uh, problems. And this type of problems usually comes every year. Please note it down, and if you have any confusion you can ask me. Okay, so this is it for today. I want to maybe give you a homework problem. Just do the same problem with PQR. It is having infinite flexural rigidity, but it is having 2 EI. Let's say EI only. This is having a flexural rigidity of EI. Let's call this length as L and this length as 2L. You just need to follow the same steps. Maybe I'll share the recordings. Just follow the same steps. There is a load W here and find out the deflection at R point. This will be a good practice for you. I'm just changing the length. You have to follow the same steps. Please try it out because it is a very important concept and it will be useful in many other problems. Okay. Okay, then thank you for today. If there are any questions, you can ask me.
Ma'am,
Mm-hmm.
in infinite values, how to use that infinite values?
I didn't get you. What? Please, can you repeat?
Uh, Beams are have some EI and infinite values.
Uh-huh.
How to use that EI and infinite values and
Uh-huh. We don't have to use any infinite value here. Just infinite value. The question that was given was the beam part, the part QR has infinite flexural rigidity. That just they just want to depict that this part EI, that this part QR will not deflect at all, right?
Mhm.
It will not bend at all. Just to signify that we don't have to use the value of infinite anywhere here.
Okay,
Okay.
thank you.
Because because if we use infinite, then only that will become zero, right? Any value divided by
Yeah.
infinite, so
Mhm.
anyhow it will not deflect. So thus, but here in this case, just to depict that part is not bending. So up till Q it is bending, and then it will go straight line after that, just to depict that.
Mhm. Okay.
Okay, so it was a gate 2010 question. See, so these questions come every year. Please this try to learn how to use the deflection formulas and implement it in any question, because they are coming every year. So just that's why I'm like repeating these kind of questions. Maybe a next session also I'll cover one such question in which you have to use the deflection formulas, because this concept is very very important. That is why I'm repeating it in many sessions. Okay, so just try to do it yourself, and after some sessions you'll be like pro in it. Okay. Okay, thank you. Then any other question? Please note down this problem and try to do it home at your home. Okay, then thank you so much for listening. Thank you for your time.
Thank you, ma'am.
Okay, thank you. I'll share the recording for you. Thank you so much.